When performing a PCR, did you encounter issues such as small sample size, precious samples, and non-specific amplification? Today, we will discuss how to amplify the target fragments we need. Non-specificity may result in low yield of target amplicons, reduced sensitivity of target amplicons, and poor downstream application effect. Watch the video to learn about 4 special PCR methods for better results. Direct PCR refers to the amplification of target DNA directly from a sample without nucleic acid isolation and purification. At the high-temperature denaturation step, samples such as cells or tissues are lysed in specially formulated buffers, and then the DNA is released. Direct PCR simplifies workflow and reduces manipulation steps, thus preventing DNA loss from purification steps. Both gradient PCR and touchdown PCR optimize the annealing temperature in the reaction system, but the principles are different. Gradient PCR means that when the annealing temperature is not very clear, in order to determine the optimal annealing temperature, multiple tube PCR is performed simultaneously on one PCR instrument. A PCR instrument that supports setting the gradient annealing temperature is required. Gradient PCR also has some shortcomings. First of all, multiple experiments are required and time-consuming. Secondly, when other PCR instruments are replaced to perform the same amplification, the optimal annealing temperature may change. Therefore, it is necessary to redetermine the optimal annealing temperature. At this time, the superiority of touchdown PCR is reflected. Touchdown PCR can obtain a good amplification effect with only one reaction, avoiding the optimization and determination of the optimal renaturation temperature for each pair of primers. In addition, touchdown PCR largely weakens the restriction of instrument performance on the amplification effect. Typically, the annealing temperature range for touchdown PCR can be up to 15 degrees Celsius, from 5 degrees Celsius above the TM value to around 10 degrees Celsius below it. Cycle 1 to 2 times at each temperature, then cycle 10 times at the lower annealing temperature. Nested PCR is a variation of PCR that uses 2 rather than just a single pairs of PCR primers to amplify a specific fragment. The first pair of PCR primer amplifies fragments similar to conventional PCR. The second pair of primers, called nested primers as they lie or are nested within the first fragment, binds inside the first amplicon and specifically amplifies the DNA fragments internal to the initial amplicon. Advantages: the present technique is highly specific, sensitive and accurate. It can give a high amount of amplicons with greater specificity. It offers amazing results for difficult templates like high GC-rich or longer templates. It's useful for the amplification of low-abundance genes, alleles or DNA sequences. Despite having amazing advantages of the conventional PCR setup, it comes up with several crucial limitations. It requires an additional primer set and separate reaction setup, which is tedious, time-consuming, and costly. Also, as we need to prepare 2 different reactions, it has a higher risk of contamination.